Next instructions in logical group instruction. The instructions are comparing instruction. Here we are comparing 8-bit data in register, memory or directly with 8-bit data in accumulator. Data are not affected in either register or wherever it is stored, but the results are shown by carry flag and zero flag. How it is shown? Suppose accumulator content are less than the comparing content, then carry flag is set. If accumulator content are equal to the given content, then zero flag is set. And if accumulator content are greater than the given content, then zero and carry both flags are reset. That is actually this instruction perform the work by subtracting the given data from accumulator data, and it decides the setting of carry flag and zero flag. So according to data stored, there are following three instructions. First is compare R, CMPR. It is compare 8-bit data in register with accumulator. Of course, it is register addressing mode instruction, 1 byte instruction. This instruction compares the content of register with the content of accumulator, and this comparison is done by using subtraction method from accumulator in that data. As earlier said, the result is shown by carry or zero flag. It is not shown by accumulator or that register because they contain their own. For example, if accumulator contains 15 hex and register H contains 57 hex, then after instruction compare H, CMP H, what will happen? As our result said, carry flag will be set. Why carry flag will be set? Because the content of register H are greater than that content of accumulator. Next, if data is in memory, then we are using compare CMP M, compare memory with accumulator. Obviously, as memory is involved, it is register indirect addressing mode instruction, 1 byte instruction, but having 2 machine cycles. This instruction compares the content of memory location whose address is stored in HL pair with the content of accumulator. Method is same by subtraction method, and hence results are also shown in carry and zero flag. For example, if we consider accumulator content 58 hex and memory indicated by HL pair content 24 hex. Suppose HL pair indicates C00 hex and that C00 hex contain 24 hex. Then after execution of CMPM, what will happen? Memory content are as less than accumulator content. Both carry and zero flags are reset. As earlier we said that there is no change in memory or no change in accumulator, but we are seeing this result in carry flag and zero flag. Both are get reset, which suggests that accumulator data is greater than the memory data. And third one is CPI 8-bit data, that is compare 8-bit data immediate with accumulator. As earlier we know, whenever there is I at the ending of instruction, there is always immediate addressing mode. So in immediate addressing mode, as only 8-bit data is involved, it is 2 byte instruction. This instruction compares 8-bit data immediately specified within the instruction with 8-bit data in accumulator. Method is same again by subtraction method, and hence result is stored in either zero flag or carry flag. Now here if we consider an example, if accumulator contained AC hex and after execution again of CPI AC hex, that is we are taking direct data also AC hex, so what will happen? Only zero flag will be set, z is equal to 0. Now the important instruction we are going to learn are rotate accumulator. There are 4 instructions: rotate accumulator left, rotate accumulator right, then same rotate accumulator left with carry and rotate accumulator right with carry. All these 4 instructions are implicit addressing or implied addressing mode instruction. Why? Because they work only on accumulator and carry flag. When we rotate accumulator, that is we are rotating it bitwise. Every bit is get changed. When we are rotating it left, then what will happen? This content of accumulator will be rotated to 1 bit, that is from A0 is the first bit of accumulator and A7 is the last bit. A0 becomes A1, A1 becomes A2, A2 becomes A3, A3 becomes A4, like that. And last bit A7, that will move to carry flag as well as to bit A0. Getting? So when we are rotating the accumulator only, RL rotating accumulator left only, then the last bit
A7 will go to carry flag, and it will as well as go to bit A0. For example, if accumulator contain 24 hex, then after RLC it changes to 48 hex and carry flag will be reset. In RRC, rotate accumulator right, what happen? We rotating the content of accumulator right by one bit, so that bit A7 becomes A6, A6 become A5, A5 becomes A4, like that up to A0, that is A1 becomes A0, and A0 bit will move to A7 as well as to carry flag. So here carry will be changed as well as data will be changed. Hence in accumulator, if we contain 82 hex, then after execution of RRC accumulator, accumulator becomes 41 hex and carry is reset. Now in next two instruction, RAL and RAR that is we are rotating accumulator through carry. When we are rotating accumulator left through carry, what will happen? That bit A7 which in the last instruction moves to carry and also moves to A0, here the previous carry will move to A0. Instead of that A7 bit, previous carry will move to A0, and this instruction is mostly used to double the number. Okay, every times we do RAL, it gets double. So for example, if we have 29 hex and previous carry is set, then after RL accumulator content becomes 53 hex. Similarly RAR, rotate accumulator right through carry. So as earlier RAC, it works same. It rotates the content right by one bit, but what happen? In the last A0 bit will move to carry and previous carry will move to A7 bit. So this instruction is used to cut the number or cut the content of accumulator to half. So for example, if A contain AB hex, then after execution of this instruction RAR, accumulator content 55 hex and carry flag will be set. So these are important instructions from logic group. We will see next instruction in the next lecture. Thank you.